When we have a higher root, then we need to be a little bit more clever. We need for this thing to turn into something that's a perfect fourth. So that means I'm going to need to multiply each part of this. I'm looking at this as if it's two separate things. I need to multiply each part of this by enough stuff to make it a perfect fourth. So the deal is, I start with the 2. If I can break that 2 down anymore, I will. Like if there's prime factors here, let's say this was like, say it was a 6, I want to break it down into 2 times 3. Or if it were 18, I want to break it down into 2 times 3 squared. But it's not. They're nice to us. It's just a 2. I want to multiply it by enough 2s so that I have like a 2 to the 4th power. So that means I need to multiply it by 2 to the 3rd. Because if I do 2 to the 3rd times 2, that'll be 2 to the 1st. Same thing with this a. I want it to be to the perfect 4th power. So I want to multiply enough a's in here to make it go up to the next multiple of 4. So in this case, again, I can just use a cubed. And I'll do that to the top, and I'll do that to the bottom as well. Now, I'm not going to leave my answer looking like this 100%, but that's how it's going to kick off. At the bottom, these two things will get multiplied together. Oops, I forgot something very important. This little 4 is obviously crucial. It's the whole reason why this problem is different. You can't leave it off. So multiplying these two things together, the shortcut answer is that we did all this stuff so that this would be a perfect fourth, and so that would be a perfect fourth. And if I fourth root a perfect fourth, I get what was there in the first place. So it does jump straight to 2a. If you're not seeing how that happens, then the long way around is to take these two things and multiply them together. So that would look like the fourth root of 2 times 2 cubed is 2 to the 4th. And then a times a cubed is a to the 4th. And of course, if I fourth root something to the 4th power, I get that thing that was there in the first place. If I fourth root something to the 4th power, I get that thing that was there. So the 4th root and the 4th power basically cancel each other out. But the top, I can't really put this inside of here, but I can at least simplify this 2 to the 3rd, and I'm definitely going to do that. So that'll be negative 3, 4th root of 2 to the 3rd is 8a cubed. That's our final answer. So the trick here is to figure out what you need to multiply this by to make it so that this will divide the powers evenly, and then you'll divide the power by that number to get it to pop out of the radical. Now there's no radical in the denominator. It's been rationalized. Life is good.